Welcome to the next tutorial in the object-based image classification series. So let me just review where we're at real quick. So I have my nape image, and as I showed in the last video, I subset this to just a portion of that nape image. And in one of the previous videos, I showed you how to create a shapefile showing node vegetation classes. I've redone that for my subset just so I had enough points in there. So it's the exact same procedure I did in that previous video, just with this smaller image. And so I have this set up. You can see that I have 7 different classes here: bear, meadow, road, shrub, trees, urban, and water. Okay, and so we have those 7 classes right there. And then the other thing we've done in the previous videos is we've segmented this image. And so you can see here the image segments that represent different similar color areas of the image, and those are what we're going to classify. Okay, so we have all that set up, and you can just see this a little better with that turned off. So you can see those segments. Okay, and so that's what we did in the last video, is we finalized the segments we were going to use for this analysis. So what we're going to do in this video is we need to be able, in the last video I actually got the information from those segments related to the image. So we got like the band information from the image for each segment. So in this video, what we need to do is we need to take these data, our point data, our truth data, and we need to link them up to the data from the image. And we need to subset these. So we need to get a training set of points and a test set of points against which we'll test our results. And so let me open this up. And you can see here that we have each of these labeled. And this one actually is not labeled. So I'm going to go ahead and edit this and delete this first row. And I'm going to just click save. Okay, and now everything is there, and everything should have a label or not have a label. It looks like we're good. Okay, so you can see that I only have one field here. It's label and identifies those different types. Okay, all right, so now what I need to do is I'm going to use Python and GeoPandas to do a lot of this. We're going to load this shapefile in. We are going to subset this. We're going to take 70% of these observations to use as a training data set, and we're going to use 30% as a test data set. We're going to subdivide those out. We're going to take our training data set, we're going to rasterize it so that we can recognize which segment number it falls under, and then we can get the segment data for those training pixels. So that's what we're going to do in Python in this video here. All right, so let me go over to our Python script. And I have this test file here that I'm using to test out the code before I run these videos so that we can move a little faster. What I'm going to do is I'm going to start a new Python file. And I'm going to do new Python file. And I'm going to call this, we'll call this truth data. And this is where we're going to start managing our truth data. And here I want to import GDAL. I'm going to import OGR. I want to import numpy as np. I want to import GeoPandas as GPD, and I'm going to import pandas as PD. And let me zoom in on that code actually so that you can see that a little better. Okay, so there we go. So I've got that set up. Now the first thing I need to do is I need to read in the raster that I'm using. I need to read in my nape image. And so we'll call this our nape data set. And this is going to be the file path C, temp, nape, and I believe it's clipped.tif. Okay. And so once I have that read in, I need to get n rows equals nape ds dot raster y size, and ncalls equals nape ds dot raster x size. Oh, sorry. This is nape fn, the nape file name, And then we need to do napeds equals gdal dot open napefn. Okay, so now we've opened that data set. We can get the raster y size and the raster x size. Okay, so now I need to read in my truth data, and I'm going to do that using GeoPandas. And so I'm going to make a geodata frame. I'll call it GDF equals GPD dot read, GPD dot read file. And this is going to be the path to my truth data set, which we can look over here. You'll see it's truth data. Oh, I'm going to stop editing there. Truth data subset UTM-12. So truth data subset UTM-12.shp. Right, so that will read in a geodata frame of my truth data. Okay, now I need to get the values for my classes, which I can do. I'm going to call this class vals, the class names, and this is going to be GDF, the name of the column, which is label, and I only want the unique values. So we'll call unique. All right, so that'll give me one instance for each one. And I can print this out as I'm doing this to make sure I get these right. And so this will be class names, and we'll print out class names. Okay, and now what I want to do is I want to assign an integer to each of those class names. And the reason I'm doing this is because when I rasterize these to get the segment number, raster isn't going to be able to hold a string. I want it to hold an integer. And so I need an integer that corresponds to those strings. And so the way I'm going to do that is I'm going to call this class IDs equals np dot a range, and this will just give me a numpy array numbered 0 to n for the number that I put in parentheses here. So the value in parentheses here is going to be class names dot size, and then I'm going to add one to this. I don't want to have any 0 values, so my first value is going to be 0, and my last value is going to be names.size minus 1. So if I add 1, it will go from 1 to names.size. And so now I can print class IDs, class IDs. All right, so we have those set up now. We have that set up so we have a class name that corresponds to a class ID. So now what I'm going to do is I'm going to save a CSV file that has this table in it that relates each class name to a class ID, just so that if I need to use it and look it up later, I have it available. And so the way I'll do that is I'll do df equals pandas dot data frame, close parentheses, start a Python dictionary with curly braces. Okay, and so here I'm going to give it a first column, which I'll call label. And here we'll give it the value of class names, and then we're going to do ID colon class IDs. And now we're going to do df dot to CSV, and I'm going to give it a file name here. And so the file name I'll give it C temp nape, and this will be class lookup.csv. Okay, so that will now print a CSV, so I have these data saved, and I can pull them up again if I need to later. All right, and we can put a space right in between so that we have proper formatting. The syntax will work just fine either way, but that'll give us proper formatting. Okay, so now I need to add a column into my shapefile that gives the ID number. I haven't done that yet. I've assigned ID numbers, but I haven't added that column to my geodata frame or to my shapefile. So what I'll do, I'm going to go GDF, and the way I make a new column is like this. So I'll do GDF, the ID column is going to equal, and I want to map the values. So we're going to do GDF label dot map, and we're going to map the values in here We're going to map the label values to the ID values. And to do that, we need to give it a dictionary that gives the map value and the new value. So I'm going to do a dict zip, and I'm going to zip together the class names and the class IDs, and that will create a dictionary here. Okay, so when I run this, what we can do, we'll just check this. I'll do print GDF head. So this will print out the first few lines of our geodata frame, and then I'll print it out. Let me go, sorry. Print GDF without IDs, and then let me copy that, and we'll come down and we'll print GDF with IDs. Okay, and so that's going to give us our geodata frame with a new column that now has ID in it. Okay, so once I have this set up, I need to now split my geodata frame into a training data set and a test data set, and I want to save these as separate shapefiles. So let me show you how we'll do this. So what we'll do here is we'll call this GDF train equals GDF sample, and I want to sample a fraction, and I want that to be 70% or 0.7 of the available rows. Okay, and then GDF test is simply going to be GDF, and we're going to drop the rows that are in GDF train. So now we have these two data sets, and let's print out the shapes of these so that you can see that they are indeed different. So we'll do print, let's go GDF shape, GDF dot shape, or training shape, GDF train dot shape, and test GDF test dot shape. Okay, so we'll print those out. And once I have these, I now want to save them to individual shapefiles. And so we can do GDF train dot to file. We're going to give it a file name, ctemp nape train.shp, and you can see the driver was already set to Esri shapefile, so we need to change that. And GDF test.to file temp nape /test.shp. And you can see up here in my autocomplete, the default driver is Esri shapefile, which is what we want, so we don't need to change the driver. So we've got train and test, which we're going to save, and after we run this, this will give us the shapefiles we need for training and for test. All right, so let's go ahead, let's run this script and make sure everything comes out correctly. All right, so to run it, we're going to go to run, and because we have a new file, you can see I can click up here, it doesn't show up with my truth data file. So go to run, click run, select truth data, and this is going to run and print the output out down here as it goes. And we got an error. Oh, C nape, so this should be C temp nape. So let's try to run this again. Now we can just click the run button up here. So let's click run. Okay. And so you can see that we got that printed out. Let's take a look at what we have here. So you can see we have our class names printed out at first. We have our 7 class names here. And now we have the new class IDs that go 1 to 7 for those class types. You can see here when we print out the head initially, the GDF without IDs, we have just the name and the geometry. When we print it out with IDs, we have the name, the geometry, and the ID. And you can see that our initial geodata frame shape has 322 rows, our training has 225 rows, and our test has 97 rows, and so that appears to have worked. Now let's just check our folder and see if those files got saved properly. So open this up. You can see I have a test data set here and a train data set here. And let's go add those into QGIS just to kind of take a look at their spatial distribution. And I'm going to turn the segments off for this. Let's go to the browser. Let's refresh our files. Let's grab our train data. And let's grab our test data. And you can see how those are distributed throughout our image there with the train in orange and the test in red. And you can see that if we turn these off, they overlay exactly on our initial truth points. Okay, so we're not going to be able, we don't have time to get to rasterizing these in this video. I will cover rasterizing the training data set in the next video so that we can then link that up to the data from the segments and begin to train our classifier model, which will use a random forest model to do that. So thanks for watching. Remember that I'm going to post the code on my website, opensourceoptions.com, and I will include a link to the post in the description. Also check out opensourceoptions.com. I currently have a QGIS plugins programming course up there. I'm working on a QGIS Python course. I have a cartography course and hope to have a QGIS course up there also in the near future. So check out opensourceoptions.com for more content and information. Thanks for watching.